Look at this equation. So this is called the Boltzmann's factor. So the energy difference, you can find out the ratio. So N2 by N1 is equal to e power minus E by RT. This is the Maxwell-Boltzmann law of distribution of velocities. Now look here. There are four different velocities you have to understand. What is average velocity? So the molecules with the C1 velocity, C2 velocity, C3 velocities up to Cn. If you sum up the velocities of all the molecules divided by the total number of molecules, you are summing up the velocities of all the molecules divided by the total number of molecules. It is called average velocity, V. Mean square velocity means you take the square of all the velocities and sum up. Square. You square of all the velocities and sum up and divide it by n. It is called mean square velocity. Root mean square velocity means it is the square root of mean square velocity. And then you may ask a question, sir, so squaring and summing up and taking the square root, what is the difference it is making? Look here. See, the molecules are not moving in one direction. They are moving in a random direction, which means that suppose if a molecule is moving from left to right, I can say which is a positive velocity. If another molecule is moving from right to left, let me say it is a negative velocity. If I put a plus and minus signs, everything, what will happen? A molecule moving in one direction will cancel out the velocity of another molecule moving in the next direction. But I don't want to cancel out that. Just I wanted to take the sum of all the velocities without a sign. But I have to substitute here only with a sign. So in order to take off the sign, what I can do? I can just square and take the square root. So that is the idea of a root mean square velocity. So I am squaring and summing up and divide it by number of molecules, which is called u square, the mean square velocity. If you take the square root of the mean square velocity, you are getting root mean square velocity, RMS value, root mean square velocity. So that is called u. So v is average velocity, u square is mean square velocity, root mean square velocity is u, the most probable velocity alpha. What is this most probable velocity? I have already given you the definition for most probable velocity. It is the maximum number of velocity of a maximum number of gaseous molecules at a particular temperature. So the most probable velocity is equal to square root of 2 by 3 multiplied by the root mean square velocity. Suppose if you want to understand the ratio among the most probable velocity, average velocity, and the root mean square velocity, it is 1 is to 1.128 is to 1.224. So this is the relation among them. Next one. Now only we are entering into the kinetic molecular theory of gases. It is called the kinetic theory of gases or kinetic molecular theory of gases. See, normally in all the branches of chemistry, the theory will come first and the practical observations will come next. But in gaseous state, the practical observations have come first and then they wanted to propose a suitable theory for that observation. So similarly here, the molecular velocity observations, the pressure, the expansion of the gas with the temperature, what is the temperature, the effect of a temperature on the molecular velocities, all these things have been practically observed. They have been observed and plenty of observations had been recorded. But a suitable theory for the observations made was not available. Therefore, various scientists worked together and they wanted to come out with a kinetic theory of gases. What is the theory behind the motion of the gases? What is the theory behind the uh, molecular motions? So the kinetic theory of the gases, this theory is applicable only to ideal gases. I have already told you what is an ideal gas. Ideal gas is the one which does not have intermolecular forces, because if you assume any intermolecular force among the gas molecules, certainly their motions will be affected by the molecular forces. Suppose if two molecules, they have attractive force, what will happen? The molecular motion will be very fast to make them come closer. If molecules have a repulsive force, what will happen? The molecules will be moving away from each other with a high kinetic energy or high speed. Therefore, the molecular motion and the intermolecular forces will have some relation. But with that, you cannot arrive at a theory. Therefore, this kinetic theory of gases is applicable only to the ideal gases. So what are the postulates of kinetic theory of gases? There are 5 postulates and 5 justifications for the postulates. The first postulate, when you take a system with the gas molecules are a large number of minute particles. The gas molecules are minute particles. A large system, a big system is containing a large amount of gas molecules, means there are a large number of minute particles. And when you compare the actual size of the particle with the total volume of the gas, the size of the particle is negligible. So gaseous system is containing a negligible particular size compared to the total volume of the gaseous system. That is the first postulate. So what is the first postulate? The gaseous system is containing a large number of minute particles, and when you compare the size of the particle with the total volume of the gaseous system, the size of the particle is negligible. This is the first postulate. The second postulate, the gas particles are in a constant rapid motion. They are always moving here and there. No particle is at rest. They are moving here and there, and a random motion and a constant motion is observed. Suppose if you take a container and fill it with the gas molecules, and if you keep there and go for 500 years and come back and see, even then the molecules will be in a rapid motion. The rapid motion of the molecules will never cease. It is continuous. That will never cease. So that is the second postulate. The gas molecules in a container experience a rapid and a constant motion. And the third postulate is the gas molecules, while they are moving here and there, they hit on each other, but their hit is highly elastic. There is no energy exchange while the gas molecules hit on each other. If you take a carom board or a billiards, when the balls hit on each other, when the coins are hit on each other, there is always an exchange of kinetic energy between them. See, one coin will lose its kinetic energy, the other coin may gain its kinetic energy. Therefore, you can observe that there will be a velocity distribution between the coins which hit each other. Because of that, it is not an elastic collision. But in the case of gas molecules, when they hit each other, both the molecules, they never lose energy. So the collision is a highly elastic. So an elastic collision is assumed. And also, the gas molecules do not show any attractive force, because we have already assumed that the postulates are based or are applicable only for ideal gases. One of the important characteristics of ideal gases is that they do not have attractive force or intermolecular forces are absent. Therefore, as they do not have attractive force, the molecules, they move freely and the motion is highly independent. Their motion is not caused by any attractive force or repulsive force. They move independent to any factor. The motion is highly independent. And the fifth postulate is why the gas molecules show pressure. The pressure is caused by the bombardment of the gas molecules on the walls of the container. So the gas molecules are moving here and there in a rapid motion. The gas molecules hit on each other, and the gas molecules not only hit on each other, they are always bombarding on the walls of the container. Therefore, the continuous bombardment on the walls of the container that exerts a force on the wall. The force acting per unit area is the pressure. Therefore, the pressure is because of the bombardment of the gas molecules in the wall. Suppose if you are blowing a balloon, when you blow more and more air, the balloon expands. In other words, the pressure is increasing. That means that more number of gas molecules are bombarding on the walls of the balloon. At the same time, if you heat the balloon will expand. Now there is no change in the number of molecules inside the balloon. Now there is a change in the kinetic energy with which the molecules hit on the walls of the container. Therefore, the pressure is not only because of the number of molecules hitting, it also depends upon the kinetic energy with which the molecules are hitting the walls of the container. Therefore, we can say it is applicable, the kinetic, the pressure is because of the bombardment of the gas molecules on the walls. Now I'm going to justify these postulates. The first postulate is justified like this. If you take oxygen molecule, hydrogen molecule or nitrogen molecule at normal temperature and pressure, if you measure the volume of the gas molecules and if you divide it by the total volume of the container, the gas or the gas environment, the percentage of the gas molecule volume will be 0.014, which means that they are minute particles and their total volume is negligible when you compare with the volume of the container, or the summed up volume of all the atoms, the particles, is negligible when you compare the volume of the entire gas itself. So that is how it is justified. In the second point, the molecules are in a rapid motion. You know, smoke is a colloid. The colloidal particular motion can be seen through a microscope. Suppose if you look at the smoke, you can see the carbon particles. The carbon particles are always in a zigzag motion. Actually, the carbon particles, they do not have any zigzag motion of their own, but these particles are hit by the gaseous molecules. So the carbon particles are moving here and there. So the zigzag motion is because of the zigzag hit got by the carbon particle by the gaseous molecules. Therefore, it is confirmed that gaseous molecules are in a constant rapid motion. This is how the second postulate is justified. And the third postulate, the collision is perfectly elastic, which means that during the collision, the gaseous molecules do not lose energy. You suppose if the collision is inelastic, then what will happen? We have already told you that the gas molecules are in a constant rapid motion. If you take a container and fill it with the gas molecules are with a constant rapid motion. And this motion, whenever the gas molecules hit each other, if the hitting is inelastic, then the gas molecules will lose energy for every hit. So after infinite number of hits, the gas molecules will completely lose their energy, and finally all gas molecules will come to rest and settle down. Whereas such a situation is not observed anywhere. So gas molecules are continuously moving. Therefore, it is proved that the collision among gas molecules is perfectly elastic. And the fourth one, there is no attractive force among the gas molecules. This can be proved when the gas is allowed to expand. When the gas is allowed to expand, immediately the gas molecules are moving away from each other. They want to be away from each other. If attractive force was found, even when you allow the gas to expand to vacuum, the gas molecules will try to be with each other, try to be close with each other. Therefore, the expansion of the gases prove, or the moving of the gaseous molecules away from each other while expanding is proving that the gas molecules do not have attractive force among themselves. And the fourth one, the pressure exerted by the gas molecules by the bombardment of the molecules on the walls of the container. This is very simple. I have already explained this with taking a balloon as an example. If you take a closed vessel, in a closed vessel, if you fill the vessel with more number of gaseous molecules, the pressure increases because more number of molecules are hitting on the walls of the container. And similarly, when you heat up, the pressure increases because the heating is done by more number of molecules with a high kinetic energy. Therefore, the pressure is due to the bombardment of the gas molecules on the walls. So these are the kinetic theory of gases, the postulates of kinetic theory of gases, and I have discussed the justification of them also.